Hello, everybody. Welcome back after spring break. Today, we're going to dive a little deeper into skill 4.1 and focus on the isosceles triangle. So I want to kind of show you the base angle theorem. So I'm going to give you the technical definition first, and then I'm going to give you a strategy of how to do these problems really well every time. So you should be copying at the top of your notes what the definition is of the base angle theorem. So this says that if two sides of a triangle are congruent, then the angles opposite to them are congruent. So you can actually see that with the arrows that are drawn, sort of a connection between the congruent sides and the congruent angles. And what we can actually see is, which is kind of important as well, is that AB is equal to AC in side length, and then the measures of those angles. So since C is opposite of AB and angle B is opposite of AC, then we can say that the measure of angle B is equal to the measure of angle C. So I'm going to show you kind of with a basic example first, how this works, and then we're going to go into some delta math problems. All right, so when I'm looking at isosceles triangle problems, I think about the concept of symmetry. So what symmetry means is that what is on one side is the same as the other side. So I'm going to actually divide this isosceles triangle evenly in half. And what I can actually see here is, let's say that this is a side length of 7 going from C to B. So I'm just going to say that CB is equal to 7. Then that means that if we want to find AB, or AC, I could say that AC is equal to X, which is also equal to 7. And I could immediately figure that out. If this is a 75-degree angle here, I could then say that this is a 75-degree angle. And we are free actually on these problems to actually add in some algebra as well. All right, the most basic problems that you're going to see on the delta math assignment for 4.1b is when the diagrams are provided. And we'll call this example 1, actually. So what we can see here is it's asking us to find LM. So it's asking us to find this red side over here. And I'm just going to kind of use a different color. Maybe I'll use like lime green. And if we notice here, one of the things that you could do is you could actually draw arrows outward from the angle. So the side that is opposite of angle M is 22. And the side that is opposite of K should also be 22. So that's what I'm doing if I'm drawing in those arrows. And this is example 1. But another way that you could actually think about this, so this is kind of way 1 of thinking about these problems. But way 2 is to actually think symmetry. So what I do is I kind of look at the two congruent angles, and then what is kind of in the middle of that is our line of symmetry. And everything kind of like mirrors each other. So this 22 is actually going to mirror the 22. And I'm just going to go ahead and put that in for my answer, and we'll check it. And sure enough, we're good. Let's actually go to an angle problem now. So we will call this example 2. So this is actually a pretty similar idea. So what I have here on this problem is it's asking us for VWU. So I would actually, if the symbols are, kind of looking a little busy for you, I would actually just go and highlight the angle that they are asking us for. So I'm just going to use maybe a green highlight on my zoom. So I'm going to go VWU. So it's asking for this green angle that I will call X. And if I am using symmetry in this, so I'm actually just going to kind of draw my line of symmetry. Notice that this side and this side are congruent. So it is symmetrical here. So if this angle is X, then this angle has to be X. And we also know that the 3 angles, so we know that the measure of angle W plus the measure of angle U plus the measure of angle V equals to 180 degrees. Since the triangles are actually adding to 180 for the angles. And then I'm just going to put the numbers in. So I'm going to write X plus 84 equals 180. So we're going to get 2x plus 84 equals to 180. So I'm just going to subtract 84 from both sides. So I'm going to get 2x equals to 96. I'm going to divide by 2. So I'm going to get that x is equal to 48 degrees, which is the angle that they wanted us to solve for. All right, our next level problem, the only thing that's different is that they don't provide you with a picture. So we're going to call this example 3. And my suggestion would be to, read the problem here. So I have a triangle called VWX. So I'm going to draw VWX. I'm just going to kind of just go in alphabetical order. And it tells us that XV and WX are congruent to each other. And I'm just going to go ahead and I'm going to draw my line of symmetry. So I like thinking symmetry for these because they are kind of rotated. So I drew in my line of symmetry. My angle W is equal to 27. And what I do like to kind of see here is if this is 27, then the angle that is on the opposite side in the symmetrical type of arrangement is also 27. So it's actually easier to solve for angle V. And then we just need to find the measure of angle X. So I'm actually just going to write that the measure of angle W plus the measure of angle V plus the measure of angle X equals to 180. So I have 27 for W and V, and I don't know what X is yet. So I got 54 equals to 1. Hold on a minute. I got 54 plus measure of angle X equals to 180. And I just like kind of keeping it in that correct notation. Subtract 54 on both sides. So I got measure of angle X is equal to 126. So note that I did not draw it to scale, but you don't need to draw it to scale because they do give you the information and what is congruent, and then you can just have 180-degree properties and kind of the use symmetry idea to help you solve the problem very, very well. All right, let's take a look now at example 4. So this is a side problem that you also have to draw the picture with. So I'm going to draw triangle BCD, and I'm just going to draw something that looks reasonably isosceles. So I got B, C, D. And I know that angle B and angle C are congruent to each other. So I'm going to mark that in. And I'm just going to go right between those two angles and draw in the line of symmetry. And it gives us that BC is equal to 15. And then it gives us that DB is 8. Now, this is why I like the line of symmetry. So what occurs on one side must occur on the other side. So because we have 8 on one side of the line of symmetry, the angle on the other side of the line, or the side on the other side of the line of symmetry also has to be the same. So we get that CD is equal to 8. And that's what's beautiful about, thinking about the line of symmetry here, in that if you know that in isosceles triangles, which sides are congruent to each other based off of the angles being congruent, you can really easily find the other congruent side with very little math involved. So that's why this base angle theorem is really, really nice to have. So with that, expect on your Delta Math today some problems where you have to draw the pictures. And then your first problems, though, will kind of provide you with the pictures to warm you up a little bit. So thank you very much for listening, and good luck